All right. In this morning, I found this intriguing integral. So then I tried to figure it out. Well, so after some trying, I noticed several clues here that we have this constant, and we know that this constant is the sum of the inverse of all natural, of the square of all natural numbers. So this is, so according to Euler, this is exactly pi squared over 6. The proof of this may be for another video. So at the moment, we just accept that this statement is true. Okay, so now how are we gonna do with the integral? We are going to split the interval from 0 to 1 into the following subintervals. So we divide into 1/2, then 1/3. This is probably not exactly accurate up to scale, so this is just some ideas, something like that, and so on. So basically, we will split the interval from 0 to 1, the floor 1 over x inverse dx, into the interval from 1 over I plus 1 into 1 over I, where I is running from 1 up to infinity, right? Because, for example, when I is equal to 1, we have the interval 1/2 up to 1, 1/2 up to 1. When I is equal to 2, we have the interval from 1/3 to 1/2, and so on. Okay, so all right. Now notice that if x is on this interval, which is, say, between, at the moment, we just use the less or equal. Later we will fix a little bit to make it correct. So if x in here, then, sorry, oh, this is not very nice to scroll. Okay, so then 1 over x will be between I plus 1 and I. We want this to be included here, so let me just put this over there. Okay, so if x is between, if x is in this interval from 1 over I plus 1 to 1 over I, then 1 over x is in between I and I plus 1. So therefore, the floor of 1 over x is gonna be odd. So the floor of 1 over x is going to be I, right? So then we can replace in this integral this this one the inverse of 1 over x into, it's just the sum of from I equals 1 to infinity. Okay, in this interval, this expression will turn into 1 over I, right? Because this is the floor of 1 over x is equal to I. So this is 1 over I. Okay, let me put this dx. Okay, so now this is the sum from 1 to infinity of, so this is just a constant, the integral will be 1 over I x, and when we substitute 1 over I minus 1 over I plus 1. So this is 1 over I minus 1 over I plus 1. And this is exactly the sum from 1 to infinity of 1 over I squared. And we can see here that this is our friend that we mentioned earlier. It's the guy. So we are on the right track. And then minus the sum of I equal to 1 to infinity 1 over I times I plus 1. Okay, this is also kind of well known, or easy to compute at least. So let's try to compute the partial sum of this. So the Sn of this series will be the sum from 1 to infinity of, from 1 up to n of this guy. But this expression can be rewrite as 1 over I minus 1 over I plus 1. So you can easily see that if we make a common denominator, then this expression is exactly that one. Oh, okay, so the mouse is not really captured by the OBS. So this is some unfortunate. So this is a telescoping sum. So it's going to be 1 minus 1 over n plus 1. So if we take n goes to infinity, this is going to be 1. So therefore, this guy is equal to pi squared over 6, and this guy is exactly 1. So there we go. That's our integral. All right, so that's a short video for this morning. Thank you for watching. See you again in the next